Hello folks, we're back with the part 7 of the miscellaneous exercise. Let's continue with the problems that we were doing. Let's see, certain cases we have u by v form, certain cases we have u into v form, so accordingly we will be solving it. The 24th problem, let's call f of x as ax squared plus sin x into p plus q cos x, and for our convenience let's call u as ax squared plus sin x and let v be p plus q cos x. So we take the derivatives, it will be derivative of ax squared and derivative of sin x. A moves out, derivative of x squared is 2x, sin x derivative is cos x, so it is 2ax plus cos x, and then derivative for this is derivative of p dash p and then derivative of q cos x. P is a constant, derivative will be 0, q will move out, derivative of cos x is sin x, so it's minus q sin x. Right, now our f of x, which is u into v, helps us to get the derivative, that is f dash x is u into v dash plus v into u dash. U for us, it is ax squared plus sin x and v dash is minus q sin x, and v for us we are expanding. Right, so do we have anything? Yeah. This alone, so minus aqx squared sin x, then 2apx p cos x, then 2aqx cos x, and q outside cos squared x minus sin squared x is cos 2x. If you want, you can write it like that. Inside the bracket we have cos squared x and sin squared x. Yeah, it's a huge thing, no? So many things are there. Actually there's no need, you can leave it like that, there's no need to expand, but just that way we do it if you want, that's all. Then we are moving to the problem number 25. It's again a product rule problem. So let's call f of x as x plus cos x into x minus tan x, and for our convenience we are calling u as x plus cos x and v is x minus tan x. Our next task is to find the derivative of x and derivative of cos x. Derivative of x is 1, cos x is minus sin x. Again here next task is to find the derivative of x and derivative of tan x. Derivative of x is 1 and derivative of tan x is 6 squared x. Your f has now become u into v, so your f dash x will become u into v dash plus v into u dash. So u for us, it is x plus cos x, and v dash for us is 1 minus sec squared x. V for us is x minus tan x, and u dash for us is 1 minus sin x. Now if we desire, we can open this, or I think it's perfectly okay if we leave it like this, because there's not much of solving that will happen. Okay, let's give it a try by chance. If something works out, fine. X minus x sec squared x, then cos x minus cos x into sec squared x, then x minus x sin x, then minus tan x plus tan x into sin x. So x and x 2x, then minus x sec squared x yeah, this also cos x as it is. Then cos x and sec squared x means one cos will cancel and one cos will remain. So that will cancel with this, right? You can just check here because it is 1 by cos squared x, no? So it will cancel. Then this already we have accounted for. Then minus x sin x, then minus tan x, and tan x sin x, it's going to be like sin squared x by cos x. I don't know whether it's of use or we can keep it like this. Okay, let's check. Yeah, we could have kept it just that way, but okay, so much we can do. Now 26 problem appears as a quotient, so we'll go for a quotient rule and do it. Let, again next one also looks to be a quotient. Let f of x be equal to 4x plus 5 sin x and 3x plus 7 cos x, and further we are calling u as 4x plus 5 sin x and v as, yeah, so our derivative is derivative of 4x and derivative of 5 sin x. So 4 moves out, derivative of x is 1, 5 moves out, derivative of sin x is cos x. So your derivative is 4 plus 5 cos x. So v derivative of 3x, derivative of 7 cos x. 3 moves out, derivative of x is 1, and 7 moves out, derivative of cos x is minus sin x. Overall it is 3 minus 7 sin x. Right. So you have your f of x now becoming u into v, sorry, u by v. So we have our derivative as v into u dash minus u into v dash by v squared. So v for us 3x plus 7 cos x and u dash for us 4 plus 5 cos x minus u for us, it is 4x plus 5 sin x and v dash for us 3 minus 7 sin x, overall divided by 3x plus 7 cos x raised to 2. Whether we expected to solve it, that's what I'm checking out. See, we don't know whether it will whether it will simplify or no, but then let's give it a try. 3x plus 7, 3x, 12x, 3x, and so 15 cos x, 15x cos x, then 28 cos x, then 35 cos squared x, minus 12x, then minus into minus plus 28x sin x, then minus 5 sin x minus 15 sin x, then like it's minus and minus plus 7 5 is 35 sin squared x. Yeah, things are simplifying. 7 cos x the whole square, 12x is cancelling, then x cos x we don't have things, only thing this 35, when we take 35 common, sin squared x plus cos squared x, you're left with just the 1. So it's like 15x cos x, 28 cos x, then 28x sin x minus 15 sin x plus 35 by 3x plus 7 cos x the whole square. That's all. We move to the 27th problem. Let's call this as f of x. Let f of x be x squared cos pi by 4, I think we'll call it as 1 by root 2 by sin x, which means it is x squared by root 2 sin x. For our convenience, let's call u as x squared and let's call v as root 2 sin x. So your u dash is 2x when you take the derivative of x squared, and v dash when you take the derivative of 2 sin x, with root 2 moving out, sin x getting cos x. So your f of x is now u by v, and therefore f dash x will be v into u dash minus u into v dash by v squared. So take the v now. V is root 2 sin x and u dash is 2x. U is x squared and v dash is root 2 cos x by v squared is root 2 sin x the whole square. So it's like 2 root 2 x sin x and this is root 2 x squared cos x by 2 sin squared x. We need to leave it like that, or if you want you can take a root 2 common and whatever, but I don't know how much it's going to help you. Yeah, so that's about it. So this is our problem number 27. There are a couple of problems, or maybe 2 or 3 problems left, that we are taking it up in the next part. Thank you.